Good afternoon, everyone. I think it's time to start. Can you all hear me loud and clearly in the back of the room? Yeah, awesome. So thanks a lot for joining my session called Safer Swift Code with Value Types. My name is Benjamin Encz. I work at Make School currently, and I spend more or less half the time developing and teaching. And ever since Swift came out, I spent a lot of time exploring different ways how we can write iOS applications in Swift and use some of the new language features. Today I hope you to provide a practical idea of how you can use value types in Swift as the foundation of your app, and just give it you as kind of food for thought if you build your next app to maybe use that architecture. I'd like to start with a cool trick that I learned from Rich Hickey, who is the inventor of the closure programming language, and that is starting a talk by using a dictionary definition of a word that you used in the title, and that is safety in my case. Safety means involving little or no risk of mishap, error, etc., or dependable or trustworthy. What I hope to show you today is that some of the things that we are used to doing in the way we program iOS apps at the moment is somewhat sensitive to error and is not always dependable or trustworthy. And I hope that I can show you that some aspects of the architecture that I want to show you basically allow us to write a little bit more reliable code. I also want to touch on the question of, should I use a struct or a class? So if you've been following the discussion in the iOS community over the last couple of months, there are a lot of blog posts. If you download the slides, you can read all of them. It includes contradictory opinions by Apple from the Apple Swift blog and the Apple developer guidelines, and also contains a lot of opinions from other iOS developers. And that is kind of one of the big questions in Swift. Should I use a struct or a class when I create my model layer? And I want to show you what the implications of that can be. So more concretely, what I want to talk about, I want to start with value types versus reference types. Just a really brief introduction to make sure that we're all on the same page for the rest of the talk. I also want to talk about why the topic is relevant now, looking at the changes from Objective-C that we have in Swift. And I want to spend the most time, step number 3, talking about a practical example. So I actually built an entire app built around structs, and I want to share the lessons learned there and show you which impact that can have on your application architecture. So let's dive into value versus reference types. A very brief example of a reference type in Swift. In this example here, it's a class. It's a very simple class with 2 fields. I create an instance of this class with the initializer. I provide a name and an age, and then I assign the value of that first variable to a second variable. Then I modify this second variable and change the age to 25. And now if I inspect both values, I will see that for variable 1 and 2, the age of the person has been updated. And that is what we call reference semantics. So every time I pass a value around, essentially all I'm doing is adding another pointer to the same object. And whenever one of these objects is updated, all parts of my code that have a reference to it will see that update. So I have shared state, and it's kind of implicit. And we'll talk about why that can be a problem in some cases. Value types are different. So here's the same example using a struct instead of a class. I again create a person. Then I assign the first variable to a second one. Then I change the age on the second variable. And now when we inspect both results, we see that the first person still has an age of 25, whereas the second one now has an age of 20. So every time a value type is passed to a function or to a different variable, that piece of code receives its own copy, and it's unaffected from any subsequent changes to that other value. And it can be useful to isolate the state, but it's also more difficult to program this way because you're not used to it. I also briefly want to talk about why it's important, or why this topic became relevant at this point in time. And for that, it's useful to take a look at the Objective-C landscape that we used to are working in, and the standard library that we used. And when you look at it, when you look at the foundation types and the C types that we used, most of them are in the reference type category. Most of them are classes. NsArray, NsSet, NsData, all of these are classes. The value types that we can use in Objective-C are extremely limited. We only have very simple wrappers around C types, for example, NsIntegers or structs, but we can't really do a lot of application logic with these types. So by the means of the frameworks that we use, we already kind of implicitly start out with a class. In Swift, when we look at the standard library, we kind of see that it's shifted quite a lot. When you look at for reference types inside of standard library, you will only find very few classes, and most of them are pretty esoteric. So you'll get a managed buffer or a non-Objective-C base. And unless you're building your own data structures, you will very likely never use these. But when you look at the value types that we see, then there are arrays, strings, optionals. So all of these standard library types are now actually enums or structs and not classes anymore. And I think that is what kind of spiked that initial discussion, if we should use structs or classes, because Apple kind of suggests maybe through this framework change that we should be doing it. Now, just because it's possible to use value types, I'm sure you're not convinced yet why it is necessary, but I want to show you a little example from the Objective-C build that a lot of you probably have seen if you've been around for a while. And that is the copy qualifier on properties. So even in Objective-C, where we primarily work with reference types that have that shared value semantic, we would use the copy qualifier to make sure that certain parts of our application actually get a unique copy. So when a value is assigned to this property, the string is copied and it is no longer affected by other changes that otherwise would be affected if it wouldn't be copied. So we already are aware that it can be a problem if we have these side effects by shared state. And I think Swift makes it much easier to actually work with these value semantics. So let's dive into the actual app that I want to present, that I built. It's a Twitter client that is built with immutable value types. I'll talk a little bit about the architecture later. You might wonder why I say immutable value types and not mutable ones. The main reason is that for this specific application, it doesn't make sense to modify the tweets, and I will show you why that is the case later. That means the entire model for this application only consists of constant values. There are structs where each field is a constant, and I can only initialize it once, and then I can't change that value afterwards. But as you'll see, the architecture is built in a way that it makes sense to do it like this. So the app that I built is a simple Twitter client, and the idea was that it has more or less functionality that you would use in your own iOS apps as well. That means I want client-server communication and also want some kind of interactivity. So I built an app that downloads the latest 50 tweets after you logged into Twitter. It displays them on a timeline. It allows you to filter these tweets. But most importantly, it allows you to favorite tweets. So if you're familiar with Twitter, you basically have a favorite button. It allows you to tell you that you liked what someone said on Twitter. And I wanted to build this client in a way that you can tap the favorite button and it actually gets updated to the server correctly. Because when working with value types and immutable state, these two features here at the beginning are actually really easy to implement. They're pretty much the same as the object-oriented programming approach. But the third one is complicated. Because I said, all of my models are immutable. That means once I create a tweet, I can't update the value anymore. I can't set favorited to true. So the question is, how will we implement that? And that's what I want to talk about throughout the rest of the talk. Just so that you have a visual idea of what this app looks like, it's only one simple ViewController, displays a timeline. I didn't put a lot of design love into this, as you can see, but you can favorite tweets, and when you have favorited them, then they show up in gray. So when implementing this, as I said, the first two features of just downloading and displaying these tweets was really easy to implement. You can take a look at the GitHub project at the end. It's really nothing special, but the thing that took a lot of time was, how can I favorite tweets in this application? How can I model change when I'm using immutable models? And I also want to take a little detour, because you might wonder why I spent so much time, multiple weeks basically reading up on this and trying to come up with a solution, when in object-oriented programming, it can be as simple as this. And it's a valid question, but I want to show you throughout the next couple of slides that it's not always as simple as just one line. But in general, when you work with reference types, when you work with classes that are mutable, if you want to favorite a tweet, then more or less you will write a line of code that looks like this. You update the model, and that is usually reflected in the view, and you're happy. But in some cases, your application maybe uses multiple threads. And we have maybe multiple threads that reference this class. And in that case, you will have to do some locking or some kind of synchronization. So if you have any kind of object that is touched from the background thread and from the main thread, we'll have to put something like this here in place. Furthermore, we have some shared state when we use classes, but we're never sure that every part of our application actually has a reference to this tweet that has been updated. There might be another ViewController or another object that needs to be explicitly informed that this change happened. And we usually do that with things like delegation, or maybe even things like notifications. So maybe another part of your application needs to know that this change happened, so you post a notification to do that. And there's still more to come, because we now have changed the tweet locally, and we have informed all parts of the app that the change happened. But the actual truth for this value lies on the Twitter server. So it's not good enough to update this locally, but we also have to issue an API request to do that. So you'll have some kind of line that will actually do an HTTP request and update this value on the server. And more or less every time you do a change with mutable models, it looks very simple, but somewhere in your model you have architected in a way that you think about all of these concerns every single time. And you have to write code for that every single time. In summary, you have to protect against unwanted updates. You can do that by locking or by copying values. You have to distribute a new value throughout the application by delegation, notifications, or some other means. And you also have to understand what the underlying identity of that object is. In this case, it is the object that lives on the server and that needs to be updated with an API request. And as I said, in most cases, you'll have to implement most of this in all places where you actually modify values. And that was kind of, once I realized that the object-oriented approach is also not that simple, I could more validate spending multiple weeks trying to learn the non-object-oriented way of updating values. Just a short visual summary of what I talked about in the last couple of slides so we can later compare it to the other architecture. Here is the object-oriented model that we typically use. And there are a few things I want to point out. The first one is you can see a lot of the arrows have two arrowheads that point in two different directions. That means we have a two-directional communication, for example, between the view and the model layer. You have your view that triggers some kind of update, and then you write it to the model. You also have the model that can update, and that then populates the changes to the view. If things get really bad, then you also have updates between multiple views or multiple models. But essentially, the idea is that you don't have any kind of formal structure of communication. You decide ad hoc where I want to propagate this change, and then you send a message to that object or that view. Another aspect that I want to point out here is that we have the multiple references. You can see tweets in orange and in blue, and you can see by these dotted lines that they are referenced by multiple parts of our app. But what I also want to point out is that we can have the same tweet that is actually one tweet on the server represented by multiple different instances of objects in our app. So here in orange and in blue, we have the tweet with the ID number 1 that represents the same tweet on the server, but we actually have two different instances that store the same information. If you, for example, work with core data, then you often have this problem because you can do fetch requests in different parts of your app, and you will get different instances that represent the same data. So that summarizes some of the complexity that we maybe aren't aware of anymore because we got so used to it. And that's why I want to come back to the safety. I think this model can be very safe if you are familiar with it, and most of us are. But there are a lot of things you have to consider as a developer when it goes about modifying state and thinking about all of that synchronization that has to happen and the state propagation. And there's a lot of room for error. So especially beginners will forget one of these steps, and then your application will not work as expected. The summary for me at that point was that modeling change is really difficult in general. It's one of the most difficult problems that we deal with when writing apps all the time. And I think it's true, it doesn't matter if you choose the object-oriented approach or a value-oriented, more functional approach. So with all this detour, let's take a look at how we can model change with immutable value types. So I read up a lot on different programming languages where this problem has been solved, and most of them basically model changes as values themselves. More concretely, that means in this specific application, every time I want to modify a tweet, I instead create a new tweet that contains that specific change. Every time I change something, I create a new value. Then I save these mutations in what I call a local change set. We'll talk about the details of that later. But the idea is to remember all the changes that a user made in a separate data set and store them there. And then again, separately, I store the latest state that I got from the server. So when I synchronize with the API, I remember what I got from the server. In a separate set, I remember the changes that the user made since the last synchronization. And then what we display on the screen is a merged view of these two different lists. So on the one hand, we have what the server told us. On the other hand, we have what the user changed since then. And we can decide what truth we can derive from these two different value sets. We'll talk about that in detail. And lastly, to actually perform the updates to the server, I also need a way to synchronize this local state and to update the tweets that I favorited with the Twitter API. To summarize the idea in a more visual form, it's actually, the basic idea is fairly simple. The local change set, a server change set, and when we merge them together, we can calculate what the user should see. Now, another problem is that this here can be the core of our solution, but I still don't know how to implement this in code. So where do I actually implement these local lists and server lists, and how do I derive them? So how do we store that state, and how do we update that state throughout the application? And the first time I gave this talk was a couple of months ago. I came up with a custom solution to do that, But then one of my web developer friends pointed me into a JavaScript framework or a JavaScript architecture that basically handles this problem for us, or has implemented a way that works pretty well. And that is the Flux architecture. The Flux architecture is used at Facebook, and there are a couple of derivations of it. But the essential idea is that in the Flux architecture, information only flows in one direction. It doesn't flow in multiple directions. That is the core feature. I'm going to show you what the architecture looks like on the next slide. And we're going to talk about every component involved in detail on, again, the next slide. But the main feature you can see here, we have arrows that only go in one direction. There's no bidirectional communication. And another important aspect is that the entire application state lives in what we call the dispatcher, that you can see in the bottom left corner. That pink tweet, that is the only state that we have. And from there, the state is passed on to other parts of the application, but they only get an immutable copy of what the latest state was. They cannot change it, but they can display it. Let's talk about all the components that you can see here on the screen. So first we have what we call an action creator. The action creator, you can imagine, is the interface from your views to your business logic. So whenever you want to perform any kind of update, when you want to favorite a tweet, when you want to unfavorite a tweet, you have to call one of these action creators. And then you pass that action creator to the dispatcher. The dispatcher is basically the part of your application that stores the entire state, and is also responsible for distributing new state. And action creators only have the goal of creating actions. We'll take a look at that in code in a second, and we'll get less abstract. Actions don't have any code themselves. They're basically just enum entries. So if you think about your application and all the different features you have on your business logic, each of them will be one entry in the action enum. For example, favorite tweet, unfavorite tweet, and so on. Then these action creators create these actions and give them to the dispatcher. And the dispatcher sends the action to what we call a reducer. And the reducer is actually the interesting part, because that is where the application logic lives for the biggest part. The reducer gets the current state of the application and an action, and from that it derives the new state of the application. So if I have a list of 50 tweets, for example, and I want to favorite one of them, then the reducer gets the 50 tweets and the one that wants to be favorited, and returns a new state that represents exactly that. Then the dispatcher takes this new state and gives it to the ViewController, and the ViewController updates the table view, and the cycle finishes. So let's dive into the code for that, because I want to make it practical, so you actually see which code goes into implementing this architecture. So first of all, how do we represent state? So I hope you're familiar with Swift. If not, what I'm using here is called a tuple. A tuple is essentially a list of values. And the application state here in this application is represented as two different lists. I talked about it earlier. We have the server state and we have the local state. I also have a second type called the timeline merged state. That is basically the same as the application state, but it has a third list of tweets, which is the combined tweets that combines the server and the local state. That is basically what we display on the screen. How do we define actions in this architecture? As I said, the actions are just enum entries. So we have an enum called action, and it has multiple entries. One of them is the mount action. That is not really important. It just sets up the initial application state. The more interesting ones are the favorite tweet action and the unfavorite tweet actions. And each of these actions can also describe which input it needs. For example, to favorite a tweet or to unfavorite one, I have to pass in the tweet that should be changed. So that is all that actions do. They're pretty simple overall. Now, how do we actually trigger the change from the ViewController? This here is the function called didFavorite, and it's a callback from a table view cell that has been tapped. And what we have to do here is we have to call the dispatcher. I said whenever you want to do any state changes, you have to call the dispatcher and pass it an action creator. So if the tweet is favorited, then I pass the unfavorited tweet action creator. And if it's not favorited, then I pass the favorite tweet action creator. And lastly, I can trigger another action called sync favorites to actually synchronize the changes that I made with the API. So the interface here from the view to the model is also not too complicated. One of the difficult parts for me when implementing this architecture were the action creators, because the action creator for favorite tweet looks like that, and it's a little bit difficult to understand at the beginning. The goal of an action creator is to provide one of the actions that we can perform on our business model. So for example, favorite a tweet, unfavorite a tweet, synchronize something, and so on. I was wondering why we need this indirection. Like, why can't I just take an action and give that to the dispatcher? The idea is that the action creator gets a reference to the current state of the application, and based on that, it can decide if it wants to send an action or not. The typical example for this is if you implement a calculator and you have a button that says, I want to increment the value by 1 if the value is odd. So only if it's 3, I want to increase it by 1. If it's 4, I don't want to. You could implement this with an action creator that takes a look at the current state, and if it's an odd number, it will return an action that increments the value, and if it's an even number, it will not return an action. So basically, you can have some application logic in here that can decide based on the current state of the application, do I want to trigger an action or not? It's not trivial, but if you go through the code, it should help. So now, as I said, the reducers are the one that actually implement all of the application logic. They're the most interesting part. And this is the signature of a function in that reducer. It's called favorited tweet. It gets as input the current state of the application, the tweet that should be favorited, and returns the new state of the application. And all of these here are pure functions. They don't depend on any outside input except the input to that function, and they don't have any side effects. They just return the new state. The implementation here is also not too complicated. The first thing we do is we create an entirely new tweet that has all the values of the old tweet, but the favorited flag is set to true. So this represents the new tweet that we want to display to the user. Then the second step is adding this tweet to the local change list. Now, I'm doing a little bit more here because I'm, in this application, always only remembering the latest local state that the user has performed. So if the user favorites and unfavorites tweets, then I always only remember the latest change. And that's why what I do here is I look up if the tweet already exists in the local change list. If that's the case, then I replace it. And if not, then I add it to the local change list. And after that, I return a state that now represents this new state that contains the favorited tweet instead of the unfavorited one. And then the dispatcher will get this new state and will forward it to the ViewController. The dispatcher is primarily boilerplate code, so it's not too interesting. But what is really interesting is the very nice interface you get in the ViewController. If you subscribe to the dispatcher and say, I want to be informed when the application state changes, then all you have to implement is one method that gets the new application state, and that can then update the UI. So here I get the timeline merge state, and I said these are basically the three lists, the server state, the local state, and the combined one. And then I grab that combined state and hand it to the tweets variable. And whenever that tweets property is updated, the table view reloads and displays the new tweets. Since it was a lot of code, I want to recap real quick which flow we have in this architecture. From the view, we talk to action creators. The action creators are called from the dispatcher, and they create actions. The dispatcher sends these actions to the reducers. The reducer actually implements the state change, returns the new state to the dispatcher, and the dispatcher sends a new state to all subscribers, including the view layer. Now, there's one last aspect I want to talk about, not on the code level, but it's also very interesting, and that is how do I synchronize these changes that I have locally to the server? And conceptually, it's actually very simple with this architecture. Because you have that local change set. You have that one data structure where you only have the changes that have been made since the last synchronization with the Twitter API. So what you can do is you iterate over each mutation in that local change set. So you have, for example, 5 changes that a user did. You go over each of them. Then you generate an API request for everyone. So if it was favorited, then you say favorite tweet. If it was unfavorited, you call the other endpoint. Then you take the responses. If the response was successful, then you know that the tweet has now been updated, so you can remove it from the local change set, and you can update it in the server set. And now you know I have successfully synchronized this local change. If the API request fails because there's no internet connection or for some other reason, then it remains in the local change set, and the next time I synchronize, I know that this change is still local and has not been synchronized with the server. So to summarize the overall architecture of this app, there are 2 main components. The first idea is keeping local changes separated from what I got from the server. That makes it easy to synchronize the changes to the server later. And the second part is the Flux-like architecture, where I have a unidirectional data flow that always goes through a central dispatcher, and where I don't have any dependence on state, and I have pure functions that derive state from the latest state in the application. So from this here, coming back to right at the beginning of the talk, should I use a struct or a class? I think it's really primarily an architectural question. It's not about the keywords. It's not about value versus reference semantics all too much, because you can use both types in pretty much the same architectures. You have to think about, do I want shared state or isolated state? Do I want mutable state or immutable one? And I think there are advantages and disadvantages to both approaches. I'm going to start with the downsides. of the value-oriented architectures as I perceive them. Firstly, it's unconventional. That means if you're working in a large team, there can definitely be issues that people do not agree with this architecture and don't want to write code in this way. It can also be more difficult for iOS developers that are used to a different architecture to actually get started with this. Secondly, it can also be difficult to integrate this into the reference semantic world that we're currently working in for the biggest part. For example, if you work with core data, you will have to work on isolating core data from this entire application architecture because core data works with NS-managed objects, there are classes, and you have to think about a clever way to synchronize that. But it is possible. It's just not trivial. But I also think there are a lot of benefits. Firstly, when we use value types, doesn't matter in which architecture, we have the confidence that no one will change the data that we received in any part of our application. That means we don't have to synchronize, we don't have to lock, we don't have to copy. We can do whatever we want with these values, and we can do any kind of background calculation. I also think it's a benefit that state modification and propagation has to be handled explicitly here. I showed you earlier, in object-oriented programming, you can just say tweet favorited equals true. But actually, it's not that simple. And it's not, when you program that way, you don't see it as a programmer. You don't get a compile error that warns you that you didn't think about locking, that you didn't think about how the change should actually be propagated. So I think that interface that we have when we work with classes that are mutable is a little bit oversimplified. And this architecture actually shows how difficult it is to deal with changing state, and it makes it very explicit. And we can also implement all of that infrastructure for propagating these changes in one single place, instead of at every place where we make the change. There are also some more benefits from just modeling change as separate data, instead of modifying these objects in line. And one example here was the client-server synchronization. If we have all of that local data stored separately, then it's much easier to provide a synchronization mechanism. I don't have to remember what was the last update I made with the server and keep a current list of all the things that I need to send to the server. It all comes for free with this architecture. And a lot of parts of the application are also easier to test because the biggest part of the application will be in the reducers. And these reducers don't have any state. Whenever you pass in the same values, these functions will return the same values. So if you want to test the reducer, all you have to do is you have to create one line to create a state. You put it into the reducer, and then you test the output. You don't have to do any mocking or stubbing around all of that stuff for the biggest part. So if you take anything away from this talk, I don't think that it has to be that you take this architecture and implement it. I think it should be that Swift has provided us with a different way how we can consider writing iOS applications using value types. And I think if you have side projects, it would be cool if you explore different ways of how you can leverage that. Thank you. I hope you have some minutes for questions. Yeah? Cool. Are there questions? Yeah. Can you go back to slide 45? 45. Oops. Yeah. Oh, 44? 45.
30, yeah. So when you do your favorite tweet, and then I think maybe 46, and you
46. Here?
The dispatch. We dispatch the.
Oh, we're dispatched. That is this one here.
Okay, so when you dispatch, and then you were saying that it goes through, and it comes all the way back around, and then you update. So we dispatch that change, and it comes through, and we update the UI. Now, is that with the background sync back to the server as well, or is it just locally changing based on the merge state?
So the question was, when we basically have the cycle of talking to dispatcher and then getting the new state, does it also involve the server update? So the first step is favoriting the tweet locally, and that will immediately trigger the update of the local state. And then separately, what happens is synchronizing the favorites. And the UI will never know if they have been updated or not correctly at this point, because I didn't subscribe to it. So in this case, there's just a guarantee that it will be updated every time I synchronize with the server. But I don't have information if it has been updated correctly. You could implement that if you would want to actually know what the server state is. But actually misspoke, sorry. You will get two different callbacks. You will get the first one with the local changes, and then you will get another one when the server changes happen, because the server state will be updated, and that again goes through the dispatcher. So you get two different ones.
So, and then when you get that second one,
yeah.
If other data has changed as well, so for instance, we're doing 50 tweets.
Yeah.
If that tweet is now in a different position, how are we going to know to scroll?
So the question was, when I get new data from the server, and let's say a tweet changed the position, how do I know how to scroll to that position? Essentially, what every code you implement in that new state function, you'll have to check what was the old state, what was the new one, and then do your UI updates accordingly. So Facebook uses this architecture together with React, which is like the same approach, but for the UI layer. If you use that, then it's much easier, because then the view is also built in a way that you say, here's the state, everything else happens automatically. But I didn't want to put these two things in one talk, because it would have been much too much. But yeah. So you either can use something, some kind of reactive layer that actually can calculate the view based on the latest state automatically, or you have to do it manually in the update state function.
And what's, at a, I guess, high level, what's the difference between having a model singleton that's shared in an objective way versus using this way, where you have a singleton and you fire an event with the object that updates the singleton, and then the singleton that's everybody else knows?
Yeah, so when you have a singleton and you dispatch notifications, the problem is you can't really scope that. So here I have one component, it's called a timeline component, and its state is entirely isolated. If you have anything global, like notifications or singletons, it's firstly pretty hard to test, because you can have multiple factors influencing that. And you also can't isolate these changes from other parts of your app. Let's say I want 2 timeline view controllers. It gets really complicated to implement that with notifications, all such kind of things. Here you can have one component that isolates the state from the rest of the application. So we had a question there?
I've seen this before, and I always think to myself, I feel like there'd just be a ton of objects created in memory as opposed to one.
Yeah, so luckily there are not too many objects created. There's the action that is created every single time. But in general, yes, when you use such kind of approaches, there's always an overhead to it. Because instead of calling directly into one function, I have this indirection over 2 or 3 steps. So you'll have to consider if there are some kind of critical paths in your application where performance is really, really important, then you don't want to use this approach. But overall, the overhead is really minimal. So for the 99% of the iOS applications, this would not matter. Yeah, but you have to think about it. It's the same when you use, for example, reactive Cocoa. It works for a lot of stuff, but there are some cases where the performance overhead is critical. Yeah.
Use of the ordering of reducer, dispatcher.
Yeah. Let's see if I get that slide. I've got it a couple of times. Yeah, so the question was the order of reducers, dispatchers, and so on. I can just recap it real quick. So you call the dispatcher, you provide it with an action creator. The dispatcher calls the action creator, then it gets an action back. Then the dispatcher takes its action, calls a reducer, gets a new application state back from the reducer. Then the dispatcher calls the ViewController with the new state, or the subscribers. Yeah.
And a follow-up question to that.
Yeah.
Your dispatcher was it was lowercase, which I assume that was a local instantiation of the dispatcher?
Yes. So the dispatcher is basically the only part that stores state, and you have to think about where you want to instantiate it. In this simple app, since there's only one ViewController, I did it directly in that ViewController. In more complex apps, you'll have to think about where the right place to store that is. Yeah.
So what are you using to manage the subscription to the changes in the dispatcher?
That's basically just the question was, what do I do to manage the subscriptions? In this simple app, I'm using an array that keeps strong references to the ViewControllers. But essentially, you want to do something like a multi-delegate. There are a lot of implementations of that. So it's essentially just an array of subscribers. And every time there's a state change, you iterate over all of them and give them a new state.
So your dispatcher is calling a method on the
Yes, that's a new state method. It's basically defined in, I didn't mention that when I went over the code, but it's defined in the timeline state subscriber protocol here. So you can see it implements the timeline subscriber protocol that requires it to have the new state method.
So how does timeline ViewController run the object? It's how the dispatcher wants to subscribe to change.
It's basically a dispatcher subscribe, and that's it. Yeah. I can. The code is actually on GitHub, so when I go back to the last slide, you can see that and download it. Are there more questions? Yeah.
So, yeah, I just have been working on a project that uses Bootstrap, React, and Flexible, which is Yahoo's kind of framework for implementing Flux. Because Flux is essentially an architecture.
Yeah. Maybe me if you like it good enough. So the question was there are basically implementations of the Flux architecture for JavaScript. Is there any open source one? And the answer is yes, I was considering doing that. I guess I would first have to figure out what is actually going into that Since it's mostly an architecture, you have to think about what is actually part of the framework, what is part of the application. But yeah. Yeah, sounds good. Okay, flexible. Cool. Another question there? Yeah. So the question was basically in the talk that I referenced, the controlling complexity. Andy Matuszak talked about that in the functional architecture you have basically the state isolated, or you have stateless functions primarily. And the question was, where is my state isolated? Basically, the whole diagram that I have here with the dispatcher would be per state that you store in your application. So it can either be one large state. If you store the entire application state in one dispatcher, that's possible. Or it can be for multiple components. But the functional part about this architecture is that 90% of the code that you write does not depend on the current state of the application. It doesn't reference anything outside of the function inputs. So the main application code, as I said, is in the reducers. And these reducers are pure functions. And that is why it's a more functional approach than, if I understand the question correctly. Yeah, okay, cool. Thanks again. If there are no more questions, yeah, thanks.